All right, welcome to problem number 9.10. One more problem 9.10. Locate the centroid of the given composite figure. You color it in. So this is some shape with a hole in the middle. We're looking for the centroid of this shaded in figure. Need to identify the x and y axis. I'll stay fairly true to the way that I do mine. You've probably noticed. I don't deviate too much. So I'm looking at this figure before we get involved in the calculations of the area anyway, but I'm looking at this figure and I'm seeing that it folds in half like a book, right? So that's tells me that capital X bar is 1/2 of 24 plus 36 plus 24, right? So 24 plus 36 plus 24, well, 24 plus 36 is 60, 60 plus 24 is 84, so 84 divided by 2 is 42. So that tells me large X bar is 42 millimeters. So that saves us a little time. All right, this is a subtraction problem for me. Well, regardless of how you do it, it's a subtraction problem. So the composite figures that I'm going to be looking at today is I'm going to look at the a large rectangle. Pretend like that's a beautiful rectangle. I'm going to subtract the two triangles from that, and both of those triangles are the same size. And I'm going to subtract a circle. Okay. So that's my plan of attack. Area of a rectangle. Area 1 is length times width. The length is 24 plus 36 plus 24, which is 84 millimeters. Oh my goodness. There we go. 84 millimeters times 72 plus 24. So 72 plus 24 is 96 millimeters. And if we multiply those two things together, we get 8,064 square millimeters. Area of a triangle, so area 2 and area 3, they are equal. Both those triangles are the same size. So area of triangle is 1/2 base times height. 1/2 times 24 millimeters. And the height of each of those triangles is given in the problem is 72 millimeters. So we didn't really have to do too much figuring out there. So 1/2 times 24 times 72 is equal to 864 square millimeters. And then finally, the area of the circle. So for me, that's shape 4. Pi times radius square. Radius is given as 15 millimeters. So 15 millimeters squared times pi. I have written down when I did it last night, it's 706.86 square millimeters. Okay. All right. So the table. So I've got shape 1, shape 2, shape 3, shape 4. The first column is area. Area for shape 1 is 8064 square millimeters. Area 2 was area 2. Let me kind of draw it up here. I probably should have did that earlier. So this is my area 2 right here. Perfectly shaped triangle. My area 3 is this triangle over here. Okay. I'll even keep it in. So area 2, 864 square millimeters. Area 3, 864. I said square and wrote cubic. I don't know what's going on with my units today. And then the area of the circle is the always powerful 706.86 square millimeters. All right, lowercase y bar. All right, for the rectangle, lowercase y bar is halfway, it's half of the height. So the height was 96, so half of 96 is 48 millimeters. For the triangle, so for triangle 2, it's 1/3 the height of the triangle. So 1/3 times 72 millimeters plus the distance from the x-axis till you get to the triangle. So in that case, in our case, that's 24 millimeters. 72 divided by 3, I think, is probably 20. Is it 24? And 24 plus 24 is 48 millimeters. It's just a coincidence. It's just a coincidence. Rectangle or triangle shape 3 is also triangle, so same deal. It's 1/3 times the height. The height is 72 millimeters, just like the first one was. And then we have to add the distance to get there. So to get to the triangle, if we start at the x-axis and start walking up, we would have to walk up 24 millimeters. And if you do the arithmetic, you better get 48 millimeters like we did in for the second one. And so well, the distance from the x-axis to the center of the circle is 24 millimeters. Give it to us in the problem. We do like that. I mean, if we had to have calculated it out, the formula for y bar would be diameter divided by 2, which would be 15. And then it's, I mean, I'm thinking it's 9 millimeters, right? I mean, if the distance from here to here is 24 and the distance from here to here is 15, so that would be 9. 9 plus 15 is 24. So we could calculate it. All right, and a y bar. All right. Let me get my sheet out where I've got the numbers. 8,006. All right, so for composite or shape 1, a times y bar is 387,072 cubic meters. The left-hand triangle, 864 times 48, 41,472 cubic millimeters. Same number for the second triangle. And then for our circle, I think that's a 7. 16764.64 cubic millimeters. All right. Now, just as a reminder, since I decided to treat this as a rectangle minus 2 triangles and a circle, I have to remember that when I add the areas, that I'm subtracting those out. That, of course, as a reminder, makes a times y bar also negative. So, all right. 8064 minus these 3 things gives us 5629.14 square millimeters. So that was our summation of area. Summation of a y bar is 287163, 287163.36 cubic millimeters. And capital Y bar is the summation of A Y bar divided by the summation of A. And I get, when I do that division, I get 51.01 millimeters. So what does that mean? So we have to go up here, and remember the centroid is, kind of how you would balance it on your fingers, how I think about it a lot of times. So X bar was 42 millimeters. We got that by inspection. You could fold it in half down the axis there. So, all right, so it's 42 to here, and then up 51. So that's 24 to the center, plus 15 is 39. So we'll call it right here. So the centroid, capital X bar, the ordered pair that describes the centroid would be capital X bar, comma, capital Y bar. That would be 42 millimeters, comma, 51.01 millimeters. So, all right, that's problem 9.1. Excuse me, I'm very, very sorry about that. That's problem 9.1. I'm going to stop the recording here and save it. I'll be right back to go to the next problem. See you in a couple minutes.